Hello everyone and welcome to another lecture. This will be lecture 4 and today we'll be talking about maxima and minima first, and after that we will be taking a look at some integrations that we can do with Mathmatica. So first we want to talk about maxima and minima, that is how you can find the maxima and minima of a function of a single variable. And as you can see that I have taken a function called x plus 2 sine x, and let's say I run it first. So, and to see how this function behaves, we need to first specify an interval, because we have a sinusoidal term over on the right hand side, and we want to restrict our attention to a specific interval because there will be hills and there will be downs because of the sinusoidal term. So let's plot it first to get some idea about it. No, I want to, let's say 2 pi to, let's say I want to do from minus 2 pi to 3 pi. I'll plot it. Oh, something is wrong. Oh yes, this one is wrong. So as you can see, there was an error while declaring the function, but Mathmatica didn't show us any warning, but it did give us a red sign over here, and if you just put this plus on it, it will just automatically correct itself. So let's run it again, and then we run the plot, and here we go. To have a better view, I want to do this like plot theme. I want to go for scientific and run it again. So as you can see that within this interval there are several maxima and minimas. So now we want to find out the critical points. That is, okay, let me comment it here. So whenever you want to comment in Mathmatica, you just put first braces and put a star like this, and you can put your comment over here. So now we want to find out the critical points for f of x. Sorry, f of x. Okay, so how do we do that? We first take the first derivative of the function and then set it to 0, and we solve the corresponding equation, right? Yeah. So if we do that, we can do it in a single line. So let's do it. We use solve, we use f prime of x, which is equals to 0 in mathematical language, and we specify our variable, right? If we do that, we see that we are getting some conditional expressions. So what is happening is that because you have a sinusoidal term over here, Mathmatica is giving you a conditional expression, and C1, it's a number that Mathematica assumed and it should belong to Z, that means integers, right? Okay, so first you can go for this solve command and you will get this, but this is a more generalized case, but we want to focus on only this interval, like minus 2 pi to 3 pi. That means my x will be restricted from minus 2 pi to 3 pi. So what I can do, I can use the command called reduce, and if you just put your cursor over here, since this is a new command we are seeing, reduces the statement of the expression by solving equations or inequalities for variables and eliminating quantifiers. So what does this do? Let's just see this example and it will be clear to you. So we want to reduce this solution, right? This is our expression, and we just want to get rid of this c's. That means we just want to restrict our attention to this interval. So if we do that, then we first have to write this, and now we have to give our condition. To do that, we have to type double and. You put a space, and the first one is minus 2 pi. Okay, the third bracket on the right hand side just went off. I don't know why, but you can always put it back up. And then you have to, oh no, this is not how you do it. Yeah, so yeah, so what I've been doing is that I have to put this less than or equal sign. So to do that, you just type less than, then equal, put a space on it. Mathematica automatically takes care of it. X, and again, sorry, oh sorry, was it 2 pi? No, it was 3 pi, my bad. 3 pi. And then you need to specify the variable you are working with. So if you do this, okay, Mathematica gave us this x's. That means minus 4 pi over 3, 2 pi over 3, minus 2 pi over 3, and stuffs like this. So these are our critical points. So how many critical points are there? 1, 2, 3, 4, 5, right? And as you can see, 1, 2, 3, 4, and 5. So from this graph we can see that this is actually making sense. And now what we want to do, the easiest way to do it is to just create a list. Let's say I want to call my list as critical equals to first type list, capital list, and just put oh sorry, now I remember. Yeah, so in this list just take these values, that is minus 4 pi, oh that went into the denominator, 4 pi by 3 So as you can see, I have declared a list. That means it's taking all this x's and it's storing it to a list. The reason will be evident very clear. The reason will be evident very soon. Is that the reason I did this is because I want to put all of these values into my function, and I want to see what are the values that the function returned to me. That means I'm putting in the critical values and I'm checking that which one is the maximum and which one is the minimum. So to do that, you just type F and type critical. Do that, and again you have a very nice format of the output. Now in case you are having trouble understanding this fraction and symbols, and you are having trouble finding which one is the maximum, which one is the minimum, just use this numerical command that we learned a while ago, and you can see that the maximum occurs at the y value, that is the maximum value is 10.1096, and the minimum is this one. And you can give conditions that your let's not give any conditions here, just write solve, and as you can see I made an error again because I didn't put this 0. Also I need to put my derivative, that is the prime, and you can see that these are the 2 points where the function intercepts the x-axis. Okay, so now the rest of the work is really easy. You just make a list, let's say critical. No, we used critical before, so let's just say we want to use cric. And one way to declare list is to directly use this second braces. So you type 5 in the denominator, 3 over here, you can put a minus sign like that, and the other one is 1/3. So this is our cric, and we just put it in. Okay, so this is not, oh sorry, we used F but our function was G, right? So if you type G, this is the values that our function G will take when we are putting the critical values of the function. That is where the tangent dy dx is 0, that is g of prime of x is 0. And again you can just, if you want to see the numerical value, just use the n command and you can see this is the maximum, this is the minimum. So now we want to talk about integrations. Let me write that up. Integration. So evaluating integrals in Mathematica is very easy. You just have to learn one command, and that is called integrate. If you type int, you can see that there is integrate option. Just put it to another functionality. You can check this, that if you have a function and the integration variable is x, this gives the indefinite integral. But we will see that you can use this command to evaluate definite integrals as well. So the first thing we know that first we want to check whether everything works okay or not. We just want to integrate x with respect to x, and the result is very evident, that is this should be x squared by 2 plus an integration constant. So let's see, and as you can see Mathematica is giving us this x squared plus 2, and it is not giving us the plus c term. So now let's say instead of x, just I want to write x minus 6. Does that work? Yeah, it works as well. So how do you define the definite integral in a Mathematica, you just do integrate, you put it. Now let's take our function that we already declared over here, that is g of x, this guy, and you put it, you just type g of x, you put a comma, and let's say I want to evaluate the integral for this function from -3 to +5. So what I need to do, first I need to put two braces, second braces, and I type x -3 and 5. I do this and you can see Mathematica gives the result in a heartbeat. So we now want to take a look at another function. We denoted it as g of x, and you can see the function is 5x cubed plus 2x squared minus 3x, and we have plotted this function for -2 to 2 interval, and we want to find the maximum and the minimum. So let's try to see within this interval what are the maximum and the minimum. So the first thing we need to do, we need to solve for the critical points. So we do solve g of x. Okay, just type this variable in. So let's take another example of integration, and let's say I want to declare a function called p of x, and let's say we take something really familiar. First you have to type square root, because we want to integrate square root over tan x. That takes a lot of time while doing work by hand. So first you type squirt, you type sq, and you can see there's a squirt. I do this and then I type tan x. Let's just write it like that, and I use integrate p of x comma x. As you can see, Mathematica gave us the result pretty quickly, and it's saying that the result is hypergeometric 2f1, and then you can see some numbers that are separated by commas. So if you are not familiar with special functions, this might be new to you, this hypergeometric term, but don't worry about it. So this is a special function, it's a hypergeometric function, and in the later lectures, that is the upcoming lectures, we will talk about how you can deal with these hypergeometric functions with Mathematica. And you can see Mathematica is showing me some suggestions, and if I plot this, Mathematica automatically chooses some specific interval. This time it chose -8 to 8, and you can change it as you want, so you can play around. Let's just -7 to 4. You can see this is the plot of this hypergeometric function, which contains 3 by 4, 1, 7 by 4, and minus tan x squared as the argument, and it is multiplied by tan x to the power 3 by 2. So let's now consider this function, but instead of square root over tan x, we just want to get rid of this square root, and I want to plus, let's say, an unknown u, and minus 5 times cosine of x. Again, we haven't specified what u is, so let's first run this function, and then we want to run this integrate cell. As you can see, that Mathematica treated this u without any problem, and if we now, let's say I want to evaluate a definite integral, that is integrate, I type p of x, and x from -1 to 3. Again, you can see that, and you can see that if you just take this interval and there is something wrong within this interval while evaluating the integration, Mathematica will tell you that integral of u minus 5 cosine x tan x does not converge on minus 1 to 3, right? Okay. Why is that happening? Because of this guy over here. It contains some natural logarithm, so that's why Mathematica is saying that it does not converge. But what if I change this interval? Let's say all positive from 2 to 3, a very small interval. Let's try to do that, and as you can see, Mathematica has given us a really nice answer, but here it hasn't shown you what is the value of sine 2 is, sec 2 is, cosine 2 is, because it is keeping things in a simplified form. And if you want to take the numerical value of it, you can just take this expression, copy it, use n command, then paste it, and as you can see, it's quite easy. But let's try to type n over here and let's see whether this makes any sense to Mathematica or not. And yes, you can see it. So this is how you can easily evaluate different kind of integrations that occurs in various kind of scientific problems. And before we finish off the discussion of integrations, I just want to add one little thing, and that is called numerical integrations. So, oh, I missed a T again, numerical integration. So, there can be some integrals that are really difficult, and by difficult I mean it's impossible to do it analytically. So, sometimes numerical approximations are needed. So, this is where the part of numerical integration comes in. And to do numerical integration in Mathematica, you just have to type n, capital N, and then capital I. You just type these two letters and numerical integration suggestion appears. Again, we take this suggestion. We want to know how this function works. So you can see that it gives a numerical approximation to the integral of the following form. That is this form. You have some intervals x minimum, x minimum, maximum, and this is our function, and this type of integral is the one that we are interested with. So let's take a very complicated expression again. I want to type x minus 2. I want to type times x cube minus 5, and let's say I want to type x plus 3, and I want to start from, let's say, minus 2, and I want to end in plus 3, and this gives you a numerical approximation. But since this guy can be evaluated pretty straightforwardly by using methods of partial fraction, the exact answer and the numerical integration answer would be the same. But the whole point of talking about numerical integration is to introduce this n integrate command. And now let's say we want to see if some integrals are diverging and converging. One way to do that is to just put them in Mathematica. If they converge, Mathematica will give you some finite answer, and if they don't converge, Mathematica will give you a warning or an error that the integral does not converge. Take for example, we want to integrate the exponential function, that is exp of x on the interval 0 to infinity. 0 to infinity. If I do this, Mathematica immediately tells you the integral of e to the power x does not converge on 0 to infinity. So this is how you can check whether your expression that you want to integrate will converge or diverge. Now let's take another example. Integrate, integrate. We want to do 1 by x, and let's say we want to do it, and we want to do it from 0 to, let's say, 20. Again, you can see this integral of 1 upon x does not converge on 0 to 20. The reason is, if you integrate 1 upon x, you get a ln of x, right? And when you put the value ln 20, there is some finite value, but at ln 0 it blows up. So that's why this integral will not converge, and Mathematica is giving you this warning that it is a divergent integral. So this will be it for today, and I hope you enjoyed it, and I'll see you guys on the next lecture. Thank you.